you so hard you can't breathe. It's great. But she's so good at pianos. Like, you know, the piano just like it's nice. It's a meaningful. What was right? Oh, I didn't. Oh, she's teaching me how to write the book of that you can't tell me what to. Yeah. This one's mine. It's so easy. I tried, okay.
For the last two questions, art and humanity, I don't understand. Like, it's like.
Using for R, using the angle that they give you, you can use that. That this would be, you could use like that this would be 16, or sorry, 36. And this would be 16.
Because I don't like
And which one would do it? The one that they give you is this, is 16. And it's a rectangle, so it can go straight across the middle. That'll be opposite of adjacent.
But
On the other one, you
it could be a little faster.
make another triangle on top.
I really do.
I'm like a Microsoft, like 1988. And you're not even like that.
Did you say
And so. I put it together.
Heck is your problem?
I put it together. I just want to make sure that like, won't they come undone?
I don't know, but I'm not gonna help you. I'm just gonna leave. Oh my god.
I don't know.
I'm not helping you. Come on, honey.
I think they might have spaces, yeah. You guys can come on in. They like looked good on her. I want him to. No.
We're watching a movie and friends.
Yeah.
And it had a little boy. Little actor, but it was like in 74, so he'd be really old, but he was cute at that time.
It's adorable.
He was so cute, and he has like this little British accent, so he's like, "Will you draw me a sheep, sir?" And it's so cute.
So it's not in French?
No.
Which is awesome.
Yeah,
Nice.
but it's weird because it's based on a French
All I
book,
get out of it is.
but there's only one English version, there's not even a French version.
Gotcha. Well, that's unfortunate.
Yeah.
You guys don't sound
Oh
like
my
No.
Okay, did you guys start your calculator pad?
Start.
No.
No?
I think I got like sick on my neck, and it was really itchy.
Ooh, like a
I
spider?
don't know. But it's like a really big striped dot.
Oh, is there not two?
Okay, well I do, since nobody attempted anything.
I tried 22 and I got stumped right on that one, so it's like, oh, okay.
Okay, so I was gonna answer questions for you today, but I do want you to attempt them first.
That
So,
might be helpful.
Olivia?
Number 22, part C. I
Okay.
couldn't figure out how they got there.
Let's go over B and C, how about that?
You haven't attempted it yet, have you?
No, I did 20.
Oh, okay.
I tried
Okay.
22 and then I was like, I got 0.68 seconds. And then I was like, okay, I got that and I know that like for B we're trying to find our
Yeah, that's
X. But I was like, what components am I supposed to be using to find it?
Okay. He runs off the edge of the board of the high dive at 4.6 meters per second and falls 2.3 meters to the water below. So what kind of a problem is this? Skylar? You can't. Well, thank you. That was my intention, was for you to. Okay, well, pause that then. Well, what kind of problem is it anyway? Yes, it's horizontally launched. He's only having a horizontal velocity, not a vertical one.
So is the 4.6 the VIX?
Yes.
Okay. And I tried that. I tried to do, because to get the X, it's the VIX times the time, right?
Mm-hmm.
And I did 4.6 times 0.68 and I just got 250.
I have to find the problem somewhere else. I don't know why.
Oh, it turned on. Yeah.
Yeah,
Well,
but
it's
it's
just
because
that-
I turned my iPad off because it's not.
Oh.
Because it was telling me that it was up there. That's what I thought it was. But it wasn't.
Oh, for that one I got 3.12. Maybe it was just my calculus. Did you get 3.12 for the
You said 3.12? Oh, well, I got 3.2, so basically.
Oh,
Yeah, 3.2.
okay. Okay, so it must have been a calculator misfunction.
Okay, and then with what speed does Matthew enter the water? So that's where you have to use one of the other equations that we don't use very often, but that would be the final velocity. And you'd have to calculate the final horizontal velocity and also the final vertical velocity.
Okay.
But would that just be 0 since usually there's no...
There is going to be there's not an initial vertical velocity, but there is going to be a final one because of gravity. You're accelerating.
So is that, do you have to use like one of the old equations that we had?
Yes. Which are on your, they are in your notes, your new notes, and they are in on that worksheet in your packet where they had all those formulas.
Mm-hmm.
They're there too. But you're looking for one that has a final velocity.
So could you just do the v of y squared equals 2g dy? Use that one?
Or just v of y equals gt.
Honestly, I'm not sure, without looking at, I need to look at them to see which one would be best.
Are we,
But if you have everything except for that one, if you have all the other things you need, then it should work.
so do we have to solve for both the final y and the final x?
Yes, and then you'll have to find the resultant of the two.
So how do we find the final
That
x?
came up.
Good.
I don't have an
Let me look at these equations. Okay, so you already know, what are the things you know?
The VIX and the Y.
And time.
And the time.
Okay, so tell me, just, so you know the initial vertical is what? What is it?
4.6.
4.6. You found the time was,
0.68.
okay, and you know the y, dy, right?
2.3.
Because it told you how far he fell,
Yeah, 2.3.
2.3. Okay, is there anything else that you know?
The dx is 3.2.
Oh, yeah.
1, 2.
Oh, the dx. Okay. So the the final x is the initial x plus at, which, since there's no acceleration, the final horizontal velocity is always the same as the initial. So it's going to be the 4.6. Right? If you think about those charts that they gave you, like when you would have to list all of the components of the horizontal, we never changed the horizontal, it stays the same.
The horizontal's always gonna be the same.
Yep.
Okay.
And because with all projectiles, the only force acting upon it is gravity, so there's no there will never be an acceleration. And then the final y is the initial y, which would be 0. I'll write it out, plus at also. But in this case, that would be 0. And so it's going to be, gravity times time. So negative 9.8 times what you got for the time specifically.
And then you have to add this first.
No, then you have to do this. Tag here. What is this?
It's 6.6.
Okay, so you're not gonna want to use a negative when you're doing the Pythagorean theorem, but you know that it's going down anyways. So it'll be the square root of and you should get
I got 8.
8.1.
I got 8.
It depends on how you round it. That's fine. Okay. Other questions? 33?
Did you go through all of them?
Yeah.
Oh my god. She's crazy.
See, good. I'm glad somebody has questions.
Well, she's an overachiever.
That might be slightly overachieving. Well, you should be happy because now she's asking questions for you.
I
Okay.
think this was, you have to find speed, yeah.
So it's probably similar to that.
Yeah,
The bar was that first report.
but, because I got confused because I thought
Your
the,
face just.
because I found the VIY and the VIX, and I thought that was the speed, so then I got confused what speed I was trying to find, but,
Probably the final.
Yeah.
Okay, I have
Fine.
it. Alright, so yeah, probably it's
so
similar.
once I get the VIX and the VI, Y, I just do the Pythagorean theorem.
And then you have to get the VFX and the VFY. But I haven't read it yet, so maybe it's not that you're in an apparent effort to earn an appearance on the Destroyed in Seconds show, Caleb attempts a bicycle maneuver in which he jumps between 2 ramps whose elevated edges are located at a distance of 1.8 meters apart. The ramps are angled at 35 degrees and located at the same height. Determine the speed that Caleb must acquire to accomplish this step. Now, this is not a straightforward problem. No, it's not. So, let's draw a picture. And it's 1.8 meters apart. And 35 degrees. And I'm guessing they want your answer in miles. Okay, determine the speed in meters per second in miles per hour. Okay. So, we need, this would be like the initial velocity actually. Because basically we're only concerned about what's happening from here to here. So we need to know what velocity he needs to have here to be able to get to the other side. Okay, so yeah, this one is not as straightforward as some of the others. So how are we gonna figure that out? What do we know? What?
The distance.
Okay, what would that be in terms of the
dx.
equations? Yes, we have our dx is 1.8. Okay. What else do we know? Yep, his angle will be 35 degrees. And so, yeah. How are we going to find the rest? What's an equation with dx in it that we know?
dx equals bix times total time.
Okay, so we don't have enough for that. And that's the shortest one. So we're either gonna need to figure out the time. Well, we definitely need to figure out the initial velocity. We know it's 35 degrees. How is he gonna get 1.8?
Would you like to see just an equation? Well, okay, we can't find the time because I don't have the vertical velocity.
Whoa. Okay.
But
What would be an equation with the vertical that we could find the time? What do you think, Kinmar?
I don't know, we have an equation that's like Vfy squared equals 2 times gravity times dy, and didn't we say that the Vfy squared is always going to be 0? Or, wait.
this is an angle launched,
Oh.
so that's not gonna work out. But thank you. Alright, why don't we listen to him for a minute? See what he says.
No, I can't at a loss. I don't know.
This is what I would call a very difficult angle launch projectile problem. As you read the problem, you recognize that there are two quantities that are given, and one of them doesn't even find itself inside of our kinematic equations that we typically use. What we have given here is that dx value is 1.8 meters, and the angle of launch theta is 35 degrees. This 35 degrees theta is the same theta that we see in our Maxwell equations that go VOx equal VO cosine theta and VOy equal VO sine theta. But nowhere in our kinematic
so
equations do we
fast.
see this theta.
It's like,
Now, the things that I also know about this projectile that aren't explicitly stated is I know that dy equals 0, that he lands exactly where he starts. It's a symmetrical trajectory. And then I always know if it's a projectile that ax is 0 and ay is negative 9.8 meters per second squared. I can infer some other things, for instance, that I know the time it takes to get to the peak is 1/2 the total time, and that the velocity vertically at the peak is 0. There's other things that I know about this problem that's true of any projectile problem of this nature. Now, if I want to solve for the VO, I'm going to have to go about it with two equations for two unknowns. And so I'll step you through that real quickly. I'm going to use the equation dx equal VOx times t. And I'm going to take the 1.8 meters and use that as dx. And I'm going to take the 35 degrees, and I'm going to try to figure that into the equation. So the equation would become this: 1.8 equal VO times cosine 35 times t. I can't take it any further than that. There's two unknowns there, VO and t. So I'll say that again: 1.8 equal VO times cosine 35, that's VOx, times t. Now I can look for some dy equations, so I do know dy is 0. So I could find the equation that goes something like this: dy equal VOy times t plus 1/2 ay t squared. And I can plug some stuff in there, and I'd end up with this: 0 equal VO sine 35 times t plus 1/2 times negative 9.8 t squared. That would rearrange to this form: 0 equal VO sine 35 times t minus 4.9 t squared, or the minus 4.9 is 1/2 times negative 9.8. Now there's still,
Okay. So admittedly, I needed to listen to him because I wasn't sure about how to solve this problem, admittedly. So yeah, good question, Skylar. Do you see what he's saying? Alright, so basically, remember when on the back of your projectiles packet, when you were saying how you could calculate, if you have theta, you go to the general, you had to come up with a general formula for how to find the initial vertical and the initial horizontal velocity. And so, to find the initial vertical velocity, it would be the cosine of theta what is it?
sine of theta is VIY over hypotenuse.
Okay. So this is just the initial velocity. So the VIY equals the initial velocity times the cosine of theta. Sine, sorry. And the VIX equals the initial velocity times the cosine of theta. So I wrote this down wrong. This is just the initial velocity in general, which we still don't know what it is. So that's where he's going. And so basically he's saying we're gonna have to have a system of equations to solve this. Okay, So we have the initial velocity and we have the time that's missing out of both of these equations. And so we have 1.8 equals, we'll just say v is the initial velocity times the cosine of 35 times t. And then we have 0 equals the initial velocity times the sine of t, or let's say minus 4.9 t squared. Okay, so does anyone see a way we could go about solving the system? Lauren?
What does just the v mean, like in front of the sine and the cosine?
That means the velocity without respect to the components. So it's not the horizontal velocity or the vertical velocity, but that would be like the angle velocity. So what are some methods for solving systems of equations? Substitution, elimination, graphing. Okay, I would suggest solving this with substitution method. It looks like the top one would be pretty easily solved for t. So if we take this and solve it for t, it would be 1.8 divided by v times the cosine of 35 equals t. You with me? And then we can plug that in for t in the other equation. So this is gonna do some trig and all kinds of stuff. This is, yeah, challenging. You can feel really smart when you're done. Okay, so v sine of 1.8